So in this question, we're asked to find the inverse. So if I'm looking for the inverse of a function, all I need to do is reverse my letters. So I'm going to put the x here, and I'm going to put the f here. You can call it a y, you can call it an f. I had a student some time ago that started writing it as f's, and a lot of people kind of correlated better this way. And then once we do that, all we need to do now is solve for that f value. So we do this the same way we do linear functions. We're going to first move our 2 away. We'll move our 2 away from our f value. Anything that's far away gets moved first. So now we have x plus 2. Those are not like terms, so we can't put them together. So now we have 5/2 f. Now you can do one of two things. You can either you can either multiply times the reciprocal, or you can multiply by 2 and then divide by 5. Either way, I'm going to do multiplying by 2 to start. I prefer to multiply times the reciprocal, but we'll take a look at that maybe on a later one. So we end up with 2x plus 4 equals, and what happened here is the 2's canceled, and this becomes f, 5f. And in order to get the f by itself, we need to divide by 5. And we divide everything by 5. It's a pretty good practice anytime you're about to do anything other than adding or subtracting to go to the other side and put a big parentheses around everything. This will remind you that everything is getting whatever math is taking place. So what I end up with is 2x divided by 5 and 4 divided by 5, and this is my function. Once I've completed this, the way I denote inverse is I put to a -1 power with our x. So this is how we find the inverse of a linear function. And that's our solution there. All right, finding the inverse of this one. So same thing, we are going to reverse our letters around. So this is going to now be the x, and this will be the f. So we're setting it up this way. One thing you got to make sure you do, never try to pull anything out of the numerator or denominator. First thing we need to do here is to kill our denominator, and we do that by multiplying by 7. And again, just like on the last problem, we're just solving for f. We want to get f by itself. So we just run through all the work we need to do here. A lot of times we're not going to have like terms. There's not a lot of arithmetic on this. It's just the algebra of moving things around. So we are now at 5f. Last thing we need to do is divide by 5. And again, it's a good idea to put a parentheses. Just remember, everything gets divided by 5. So the 7 divided by 5 is 7/5. The 5 divided by 5, 25 divided by 5 is 5. And the f is by itself. Once it's by the self, tack on the -1 power, x, and then we have our solution. All right, now we're also going to graph and see what inverse look like compared to the original function. So if we're given the f of x function is -4x plus 3, we're going to first solve this thing down. We can flip our letters like we've been doing. Put the x here and the f there. And then we solve for f. So I'm going to start by subtracting the 3 away, followed by dividing by -4. So we end up with x minus 3 equals -4 f. And then again, remember, we've got to divide everything by -4. If you need to put parentheses to remind yourself, do that. but everything gets divided by -4. So we end up with -1/4 x plus 3/4. This is my inverse function to the f function. So we'll graph these two functions. The first one had a y-intercept of 3 and a slope of -4. That's down 1, 2, 3, 4 over 1. So the line would look like this. And then the second function had a y-intercept of 3/4. 3/4 is right about here. And a slope of down 1 over 1, 2, 3, 4. And up 1 over 1, 2, 3, 4. So our two lines that are inverses look like this. And the main thing I want you to notice is inverse functions are always reflected across the y equals x line. That is the diagonal line connecting the two corners here. Every point that this one has, this one should have the reflection of it. So if I have the point 0, 3, which you see on the blue line, you see my graph's off just a little bit, or yeah, 0, 3, I should have a point at 3, 0 on the other line, which I would have, it's just my line's not straight. Same thing here, I've got a point at 0, 3/4. There should be a point at 3/4, 0 on the green line. Correction, the blue line, which we see right there. So if they are truly inverses, they will be reflected across this diagonal y equals x line.